This lecture will continue our discussion of structures. So, if you remember our earlier lecture, we were saying that user defined structures are user defined types which will be treated by C in pretty much the same way as the basic data types. So, we will continue on that theme and look at a topic on pointers to structures. Okay. You know that for a basic data type you can define a pointer to that type. I can declare in star or character star and so on. Similarly, does it make sense to talk about struct point star, for instance? Let us look at an example where it makes sense. So, let us go back to the example of struct point and struct rectangle from the earlier lecture. So, let us say that struct rectangle has 2 points which are left bottom and right top, and both of them are struct point. Now, we want to calculate the area of a rectangle. So, you have a rectangle R which is initialized to 0 0 1 1. So, left bottom will be 0 0 and right top will be 1 1, and I want to compute its area. Now, the area function is defined as follows. It is a function that returns an integer. It takes as parameter a struct rectangle, and it does the following. It does r dot right top dot x minus left bottom dot x star right top dot y minus left bottom dot y. So, it does that particular function and it returns it. So, we know that we can pass structures as parameters and also return structures from functions, but is it efficient to pass structures or to return structures? And the answer is usually no, because copying a structure involves copying all its subfields. So, generally when you call a function, the value has to be copied onto the function's local scope, and we have seen this when discussing functions. So, when you pass a structure, the entire structure has to be copied. Similarly, when you return a structure, the entire structure that was created inside the function has to be copied back. This is usually an expensive operation. So, one way to get around it is to pass a pointer to the structure. So, what should be done to pass structures as functions in an efficient manner? Okay. Now, one way to do it would be to define what is known as a pointer to a structure. How do you define a pointer to a structure? You define it pretty much the same way as pointer to any other data type. Had this been an integer, you would declare in star pr. So, if you want to declare a variable which is a pointer to a structure, you would define struct rect star pr. So, pr is a pointer to struct rectangle. Okay. So, now how would you pass the argument? You would say address of the rectangle R. So, you would say area and the parameter is address of R. Now, inside the function, earlier you remember it was pr dot right top dot x. Now, pr in this case is just a pointer to a rectangle. So, we have to access the variable in that address. How do you do it? Using the star operator. This is the same as addressing any basic data type. You would say that star pr would be the address, would be the variable in that location. So, in this case it would be star pr would be a struct rect, and that struct rect dot right top dot x minus star pr dot left bot dot x and so on. Okay. So, the lesson here is that instead of passing structures, you pass pointers to structures, and now whatever be the size of the structure. So, you have a struct rectangle which inside has 2 points and so on. So, you may be copying a very large, you may want to pass a very large structure, and copying that will take a long time, but instead what you do is you pass just a pointer. Now, regardless of the size of the structure, only one pointer is copied. Okay. So, the same principle goes for returning structures as well. When you return a structure from a function, what you would do is to return a pointer to that structure. Of course, now the structure has to be allocated on the heap rather than the stack. Okay. Now, let us see how the memory depiction of this looks like. So, PR, when you define struct rect star PR, PR is a pointer to a structure of type rectangle, and then what is happening here is that if you want to access the y coordinate of the left bottom, you would say star PR dot left bot dot y. So, it will come to the left bot field of rectangle and pick its subfield y. So, star PR dot left bot dot y would refer to this location in the memory. Similarly, star PR dot right top dot y would be this location in the memory, and so on. So, you can address the subfields of the fields of a structure using pointer. There is one syntactic convenience that C provides you, because addressing structures is a fairly common occurrence, and because in this case by associativity you cannot omit the parenthesis. You cannot say star PR without parenthesis, because it means PR dot left bottom and star of that. So, that is not what you want. You want to say that take the structure in the location star PR and take its left bot. So, in this case by its associativity and precedence rules, you have to include these parentheses, you cannot omit them, and this is inconvenient. Therefore, C provides a syntactic convenience which is PR arrow. Okay. Arrow is actually two characters, it is a dash and a left angle bracket. So, PR arrow left bot is the same as within bracket star PR dot left bot. So, there are two ways to address the fields of the location pointed to by PR. So, PR is a pointer to a struct rect. You can access its left bot by saying star PR dot left bot or PR arrow dot left bot. Notice that these two characters dash and left angle is just a single operator. Okay. And they have so dash left angle, that is the arrow operator, and dot have the same precedence, and both are left associative.